Hello everyone, today I am going to explain the solutions for AtCoder Beginner Contest 241. I will explain the solutions for problem A to E. So let's get started with problem A. The problem states that there is a device with a screen that shows a single digit number and a button. When the screen is showing a number k, pressing the button once changes the number on the screen to AK. The device currently shows 0. After pressing the button 3 times, what will be shown on the screen? So there is nothing about this problem. We just have to take the input of this as an array in a 0 index based array, and then we have to just fetch the consecutive indexes. I mean not consecutive, the corresponding indexes. Like initially my index will be 0 and I will first access the a of 0th, and then that will be my current index, and then I will again access that index and get the next index, and after that I will do the same again. I will do this thing for 3 times and finally that will be my answer. There is nothing to explain about this problem. So now let's move to the second problem, pasta. The problem states that there is pasta consisting of n noodles at Takahashi's home. The length of the ith noodle is ai. Takahashi has a meal plan for the next m days. On the ith day, he is going to choose a pasta noodle of length exactly bi and eat it. If no such noodle is available on any day, his plan fails. Additionally, he cannot eat the same noodle on multiple days. So basically the problem says that we will be given n different type of noodles and we will be given m days. Now on each day Takashi wants to eat some specific type of noodle, and only he can eat that noodle if that noodle exists in somewhere at in the n days. Otherwise he can't take it, and then we have to print the answer no. For example, let's say for n equals to 5 and m equals to 3. Okay, now let's say the types of noodles we have are first day we like n types of noodles are 1, 3, 7 and 8. Now let's say on the first day Takashi wants to eat a noodle of type 8. So we have 8 type noodle, so we will give this noodle to Takahashi and we will remove this noodle because the same noodle can't be eaten more than once. Then let's say the next types of noodles are 3 and 1. So 3 exists, so he will eat this noodle and this will be removed. Then 1 noodle also exists and 1 will be eaten and it will also be removed. Now if there was a type of noodle like 10 does not exist in the list, so then we have to print no, because he can't eat a type of noodle a noodle of type 10. So this can be done using multiset, which is also very easy. So first I will take the input like the types of noodles in a multiset, and then for the m days I will take the input that what type of noodle he wants, and I will check whether that noodle exists in my multiset or not. If that does not exist, in that case I have to print no and return. Otherwise if that exists, then he will eat that noodle, and also that noodle has to be removed from the list now because he cannot eat that noodle later again. So I will just erase that noodle and I will keep going this I will keep this doing for m times, and after that I will print yes. So again this problem was also very easy. Now let's see problem C. In problem C, there is a grid with n horizontal rows and n vertical columns, where each square is painted white or black. The state of the grid is represented by n strings. Si. If the jth character of Si is hash, the square at the ith row from the top and the jth column from the left is painted black. If the character is dot, then the square is painted white. Takahashi can choose at most 2 of these squares that are painted white and paint them black. Determine if it is possible to make the grid contain 6 or more consecutive squares painted black, aligned either vertically, horizontally or diagonally. Here the grid is said to be containing 6 or more consecutive squares painted black aligned diagonally if the grid with n rows and n columns completely contain a subgrid with 6 rows and 6 columns such that all the squares on at least one of its diagonals are painted black. So basically this problem says that we will be given a grid like this, and we have to tell whether it is possible to get a consecutive get at least 6 consecutive blacks in either row wise or column wise or in any diagonal wise direction, where we can at most color 2 white cells to black. So for more clear understanding, let's see image of this problem. That let's say this was like this, the grid is like this one, and like this one. Okay, there will be more like this. Now we have to check whether we can get at least 6 lengths a row or a column or any diagonal direction like this or this, so that in that portion we can get consecutive 6 black grids, where we can change at most 2 grids to make it black. Like let's say we choose this row, can we make it a portion where so that there are 6 consecutive black grids? Actually yes, because there are 2 white cells and we can simply turn them into black, because at most we can do 2 operations. So we will turn these 2 white cells to black cells, and now this portion has 6 black cells consecutively. So for this grid the answer is possible. So this is actually a implementation based problem where we have to check for each row. Like for each row we have to check all the portions of 6 rows in this row. Like for this row we have to check first this part, whether it is possible to get a required portion from this part. If not, then we will again check for the next part, like the consecutive 6 cells, and then for these 6 cells. If it is not possible for this row, then we will again check the same for this row and this row. We will keep doing this. Then also we have to check for all the columns also. Then we have to check for all the diagonals also, for these diagonals also, for this these directional diagonals. And if we can not find any portion where we can just get 6 consecutive blacks by drawing at most 2 white cells to black cells, then our answer will be no. And also in this problem it is said that summation of Si is n, which means the all total cells will be at most 1000. So we can use a brute force approach to check this. So this is the code. Initially first I take a vector of string and I take the input in that one. Okay, now first I check for each row that whether we can get the consecutive 6 blacks in any row or not. So I go to each row for i0 to n, and I have to check each segment of 6 length. For each row I have to check, like for if this is the row 1 2 3 4 5 6 7 8 9 10 11 12, then I have to check for first 6 consecutive cells whether we can get the required portion from here or not. If not, then I will check for this part, right? So this way for each row, see, we will go up to this point, right? Because at this point 1 2 3 4 5 we will go up to this point, because when we are here then the consecutive part will end at the last cell of this row. After that there won't be any at least 6 length subsegment. So we will check for up to n minus 4. So for j0 to less than n minus 5 I check for each segment, and current means that how many white cells are there. So I increase that when there is a white cell, and then I check for this segment whether the current's value is less than equal to 2 or not. Because if there are less than equal to 2 white cells in this subsegment, I can simply change those 2 or one white cell to black, and this will form a 6 consecutive black cells. So in that case my answer will be true and I will print yes. The same way I check for column also. For each column I check the 6 lane subsegments, and if somewhere I find a segment where the number of white cells are less than equal to 2, my answer becomes true. I will print yes. Then I have to check for the diagonals. Now there are two types of diagonals, like one will be this one and another will be this one. Now how will you check the diagonals? I have created two functions for that. For one checking this diagonal, and I have named this one as S diagonal or secondary diagonal. Now if we draw a table, we can see how the diagonals coordinates are changing. Like if this is 0 1 2 3 0 1 2 3, so this is 0 0, this is 0 1, this is 0 2, this is 0 3, 1 0 1 1 1 2 1 3, 2 0 2 1 2 2 2 3. So basically see, when let's say we check for this one, this diagonal, like this diagonal. So first our x is 0 and y is 1, then x is 1, y is 1, then x is 2, y is 3. So basically x, every time we move this direction, this direction, x increases by 1, also y increases by 1. And when we move this direction, like this direction, then see, x first was 0, initially it was 0, then it becomes 1, then it becomes 2, and y keep decreasing by 1, 3 2 1. So for this direction, x increases by 1 and y decreases by 1. So my this function diagonal, I check for the six size diagonal, like from every cell I try to check the six size diagonals. The same way I calculate the number of white cells in that diagonal, and if this is less than equal to 2, then I return true, because it is possible to get the at least 6 sized consecutive black cells from that diagonal. And I check for the main diagonal here. Then the same way I check for the secondary diagonal, and if somewhere I find that required subsegment, then I will print yes. And if I did not find any subsegment till now, then it is not possible to get any subsegment in the whole grid, so I print no. So that was problem C. Now let's see problem D. Now in problem D, we have an empty sequence of A. Given q queries, process them in order. Each query is of one of the following three types. The first type is 1x, where we have to insert x to A. The second type of query is 2xk. This type of query means among the elements of A that are less than or equal to x, print the kth largest value, and we are also given that k is not more than 5 at any point. If there are less than k elements of A that are less than or equal to x, then print -1. And the third type of query is among the elements of A that are greater than or equal to x, print the kth smallest value, and again k is no more than 5. And if there are less than k elements of A that are greater than or equal to x, then print -1. So basically this problem says that, let's say initially there are three types of queries. The first query, in first query we will be given an integer x, and we have to insert this x in our sequence A. Okay. In the second type of query, we will be given two integers x and k, and let's say currently our sequence have some elements. Okay. Now for second type of query, we have to print the kth largest value, which is just less than or equal to x. So if this is x and these are smaller value than x, then we have to print the kth largest value, which is smaller than or equal to x. And same way for third type of query, x and k, we have to print the kth smallest value, which is just greater than or equal to x on this side. So this problem can be done using multiset, and I think this problem can be done using ordered set also, but I did it using multiset. So yeah, let's see the implementation. Also in this problem there is nothing to explain much, it's just a implementation based problem. So yeah, let's see it. So initially I maintain a multiset because whenever I have to input a number, I will input it in my multiset, because in that way my numbers will be stored in a or sorted way in the set. Also there will be duplicate elements, so I need a multiset instead of set. Now first I input the type of query. Now if type is 1, then basically I have to do nothing but insert the element in my set, so I insert that. In the type 2, what I have to do, I have to do among the elements of A that are less than or equal to x, I have to print the kth largest element. So let's say the elements are 1, 2, 3, 7, 8, 9 and type of query is 2. Now my x is, let's say, 7 and my k's value is 3. Okay, now I have to print that element, print the kth largest value which is lesser than or equal to x. So the first value which is lesser than or equal to x is 7 because x is 7, the second value is 3 and the third value is 2, so I have to print 2. Now if my x was 2, in that case my first value was 2, the first largest value, the second largest value was 1, but there is no third largest value because there does not exist at least k elements which are less than equal to 2, because there is only 2 elements but we need at least 3 elements, so in that case we have to print -1. So I take the input and I find the upper bound of the x, like if my x was 7, my it points at this one. Now I need the third largest value, so I will do k minus 3 times. I will come here, then I will come here, then I will come here, and this will be my answer because this is the third largest value, right? Because 8 is greater than 7, so when I do it minus minus, this value will either be equal to 7 or less than 7. So this is the first largest value, this is the second largest value, and this is the third largest value. So initially my answer is -1 in case I don't find it. Now while true, I am doing that if my k is equal to 0, that means this is the element I need, so my answer will be star it and I break from the loop. And in case it is my begin of the set, in that case my answer won't exist, like there is no kth largest element, so I will break from the element. Otherwise I will just keep doing it minus minus to go in the backward direction, also k minus minus. Now why I do break from the loop when it is equals to st begin, because let's say currently I am at this element, my it is at here. Now if I do it minus minus, I will go outside the set, so that means there does not exist any answer for this query. So that's why I am breaking, because if I don't use this condition, sometimes what happens, it gives runtime error and sometimes it cycles back to this value, so it will give wrong answer. Okay, and the same way for the third query, I have to print the kth smallest value greater than or equal to x. So if type of query was 3 and my x was value 2, so this time I have to print the element greater than or equal to x, right? So what I do, I first find the lower bound of x, so this will give me this will be the it, so this is the first smallest value, right? Then this will be the second smallest value, so I have to increase my it 1 times because this one is the first, the lower bound itself is the first smallest value. So in this case I have to do k minus minus 1 times, a k plus plus, like I have to go in the forward direction for k minus 1 times. So the same way initially my answer will be -1, and if I reach it equal to st.end, that means we have come out outside the set, so there does not exist any answer, so I break from the loop. And in case k is equals to 1, that means we have reached to this element, the required element, so my answer becomes the star it and I break from the loop. Otherwise I just keep decreasing k and moving forward by it plus plus. and finally I print the answer for this query also. So this was problem D. Again, this problem was also implementation based. And now the last problem, E. Now in problem E, we are given a sequence that is a n-sized array, and there is initially empty dish. Takahashi is going to repeat the following operation k times. Let x be the number of candies on the dish. He puts a x mod n more candies on the dish. Here x mod n denotes the remainder where x is divided by n. Find how many candies are on the dish after the k operations. Now we cannot just keep running a loop for k operations because the value of k is up to 10 to the power 12, which will lead to TLE. So we have to do something else. Now initially, now one more thing to check, that the value of the length of the array is at most 10 to the power 5. Okay. And initially what I did, I just write this example to write on my copy and just try to check what is happening. So let's see that what happens. So the value of n is 5, k is 3, and the array is 21631, 21631, and this is at index 0, 1, 2, 3, 4. Now basically what the problem asks is that initially we have a dish with 0 candies. Okay, so let's say we have candies 0. Since we have 0 candies, we will go to the 0th index and we will pick how many candies are there. So we will pick 2 candies. Now our candies will be 2. Now we will go at which index? See, value of n is 5, so we will do current candy numbers, which is 2, mod 5, which is 2. So we will go to the second index and we will pick how many candies are there and we will add them in our dish. So we will add 6 more candies here and it will be 8 candies. Now again we will go to another index, but how we will get that value? The value of index. So now we will do 8, our current candies number, mod n. So this time the value will be 3. So we will go to the third index. Okay, now in third index there are 3 candies, so we will pick that. So now our current candy will be 11 candies, and we have done this operation 3 times, right? And we are given k equal to 3. So now we will stop and our answer will be 11. So in this case there is no problem because k is less than equal to n, right? But when k is up to 10 to the k is at around, let's say, 10 to the power 12, we cannot do this operation. So how will you do it more optimistic? I mean, how will you optimize it? So I want to first tell you one thing, that let's say there is a number 12 and we add 7 with it, we will get 19. Now let's look at the last digit, it is 9. So when a number with last digit 2 is added with 7, it gives 9, which is very simple. But just see for one more number which ends with 2. So let's say the number is 2232, and if we again add 7 with this number, the sum we will get is 2239, and for this number also the last digit will be 9, right? The last digit will be 9. So how will this observation help us? So let's see it. Let's say, take the example 21631, right? Two, 1, 6, 3, 1. N is equals to 6. This is 0th index, 1, 2, 3, 4. Now let's say here it was given k equal to 3. Now it take k equal to 1, like we will do 11 operations. So initially my candy is 0. So from 0th candy 0, where will we go? We will take the 0th, because 0 mod 6 is 0. So we will pick this one. Now our candy will be 2. right? Now 2 mod 6 will be 2, so we'll pick 6 candies because at index 2 there are 6 candies. So now adding 6 with 2, my total candies will be 8, right? Now 8 mod 6 is 2, so I will pick 2 candies again, 6 candies again, so it will be 14, right? Again for 14, my 14 mod 6 will be 2, so I will again go to index 2 and I will pick 6 candies again, it will be 20. And actually it will keep happening, like every time now the index 2 will come, okay? But this was the example where it came so early, like the cycle is only 1, so just let's do 4 9 5 6 11. Okay, let's see what happens in this case. I hope this will be a better example. So initially my candy is 0, I pick 6 candies. Now 6 mod 6 is 0. No, this one also, oh sorry, the value of n is 5. I'm really sorry for that. The value of n is 5. So yeah, I take, initially my candy is 0, then I take 6 candies. Now 6 mod 5 is 1, I take 11 more candies, my total candy will be 17. Now 17 mod 5 is 2, so I will take 4 more candies, it will be 21. Now 21 mod 5 is 1, sorry, 20 mod 1 mod 5 is 1, so I will take 11 more candies because at index 1 there are 11 candies, so it will be 32. Okay, so see here it was index, first I came to index 0, then for 6 I came to index 1, right? Then came index 2, then for 21 the index will be 1, then for in 32 index will be 2. So you see that once I from 1 to 2 I come, then again for 1 I come, once I come 1 it will keep repeating, like there is a cycle. And why is there a cycle? The reason is, see, if there are x candies and let's say if there is a index I and there is another index j. Now if at the ith candy there are ith index there are x candies, currently you have some value, let's say you have currently some candies, give me 1 second please. So yeah, if I am at index I, okay, and currently I have some value, let's say a, like I have currently a candies. Now if I add x more candies with it, and for that if this mod n becomes j, so I will come from here to this index, and let's say after going some more indices I again come back to this index I. What does that mean? So when initially I was at index I, my current candies was a, current number of candies were n, so which means a mod n was I. Now again let's say I have some more candies, obviously because I have went to some more indices. So now for b candies I have come back to the index I again, which means b mod n is also I, right? Now previously I showed you that if 12 mod 10 is 2, right? Now if I add 12 plus 7 I will go to 19. Now if currently my another number is 32 and I add with 7, then I will again get 39. So in this case also I get the last digit 9, in this case also I get the last digit 9. So what I am trying to say, when I will come back to this index again. From this index I know where I will go. I will go to this index j again, because previously when my a mod n was I and adding this value x, gave me some value for which I went to j, it will give me the same mod value again. I hope I can explain, I am making you understand it, that if index at 0 I had 12 candies, currently I have 0 candies, and let's say at index 2 I have 3 candies. So initially I have 0 candies. Okay, now if I add these candies, because I will come to index 0, I add 12 candies, so my current candy becomes 12. Now let's say n is 10, so 12 mod 10 will be 2, so I'll go to index 2. So from 0th index I came to index 2. Okay, now from index 2 I add 3 more candies, I have now 15 candies. I go to index 5, right? Now let's say I do some work and I come back to this index, not necessarily 0, let's say I come back to this index again, like this index 2. So once I have previously reached come to this index 2 and I have come to this index again. Now see, when I have again come to this index 2, why I have come to this index? Because obviously just coming up before coming this index, before coming to this index, my total number of candies was some x by modding some x, for which x mod n was 3, x mod n was 2. That's why I come to index 2. Now previously also when I came to index 2, my value was 12, for which 12 mod 10 was also 2. So as I showed, now let's say I have from 3 I have gone to like 15. Now I have came to index 5, right? Now again for 12 that time from index 2 I went to index 5. Now again this time I have some value whose last index last digit is 2, so let's say this time it's 42. So again I will add 3, because that time also I added 3 because the number of candies at a index is fixed. So this time it will be 42 plus 3, 45, and again by mod with 10 it will give me index 5. So I will again come to index 5. So once I come to a previously visited index, it forms a cycle, like this cycle will keep happening. So if somehow we can calculate that how many operations are we doing in this cycle, like operation means from going to one index to another index is operation. So let's say our cycle looks like this: from there we go to here, from there we go to here, from there we go to here, and then we come back to here, then we come back to here. Okay, the picture is actually like this, forget this part, we come back to here. So this is a cycle, like from here then we come back this path, right? So how many operations are doing here? 1, 2, 3 and 4 operations. And if we know that how much candies we get in one operations, let's say we get 20 candies for the visiting this many indices. So if our k is, let's say 102, okay, so we know for 4 operation we will get 20 candies. So 102 by 4 will be 25, and there will be left 2 more operations. So we know that for 25 operations we will get 25 into 20 candies, and then we can just simulate these last remaining operations. So that is the main observation of this problem, that after some time there will be a periodicity, it will keep repeating. Now in the worst case, like here it is the periodicity is coming, the cycle is coming after some time, but in the worst case how many operations it may occur after getting the periodicity? It will be n. Why so? Because if our array is like this, like every value contains 1, right, then initially our candy will be 0, we will add 1 candy, we will come to, let's say our n is 10, n is 10, yeah, I will come to index 1, then I add 1 more candy, then 2 more 10 will be 2, so I come to this index, then I come to this index, like it will keep happening. And after all this, after coming to all these indices, then again like it will be 9 now, so I will have 9 candies, then 9, I adding one more candies, it will be 10. So I will come back to this one again. So at most there will be n operations in a cycle or lesser than that. So that is all we have to do. So let's see the code. Now one more thing I would like to tell you, that it is not necessary that if you start from, you will always start from 0th index, right? But it is not necessary. The cycle will form like this, like 0, then 2, then 4, then 6, then 0. It's not necessary. It may happen that you start from index 0, then come to index 2, then 4, then 5, then 7, then 4 again, then 5, 7. Like this part is never included in the cycle. It will just occur one time before, and then this cycle will keep happening. Okay. Now as I told you that this, after consuming this cycle, there may still be remain some more operations. Let's say this is x operations. Now from where will that start those operations? Like this operation will happen sometimes and it will end at 7 index, right? Then for the remaining operations we will start our operations from this index 7. And also we have to calculate the before part, that which part is not occurring in our cycle. So let's see how I did it. First I take the input n and k, and I take the input in m, the array. Now I maintain a last. I will tell you later what it does. So I have maintained a set which will tell me that if I have visited this index previously or not, because that will help me to understand that if the cycling is occurring now or not. And also I have used mp. I don't think I have used it later. Yeah, this mp is unnecessary. I have not used it anywhere. So initially my sum is 0. Sum means how many candies I currently have. Okay. And I have currently initially steps 1, because I will perform one step at first. Now I run a loop. My current index is sum mod n. That is what the problem states. Now I check if my current index is already visited or not. Now if my current index is already visited, that means the last index is current index, because if this is the happening, right? So that means 1 is comes again, so the cycle starts from 1, right? The cycle, this starts from 1. So it's actually not last, it's first, but let's see the list of the code. Last is current index and I break from the loop. Otherwise I put order in my order array, the current index. I add the sum, like total candies currently in my sum, and I mark this vertex, this index visited, and I have used one step, so I increase the step by 1. And sometimes it may happen that k is less than n, so I check whether my steps is greater than k or not, because if I already consumed the required number of steps, then I don't need to do it anymore. So I break it, and I also mark done. So if it is done, then I simply print sum. Otherwise, now as I told you that I have to I showed you that I have to maintain the sum which is not coming in the cycle, it is just coming once. Just like I showed that, if the cycle is like this, 0, 2, then 1, 3, 4, 1, 3, 4. Okay, so this part is never included in the cycle, so I have to maintain the sum for this also. That's why I have maintained a order vertex, order array, which will in which I will keep pushing the indices which I am currently visiting. Like this is the order vertex, order array 0, 2, 1, 3, 4, and it will be like 1, 3, 4, because after that 1 will come again and I will break from the while loop here, because that is already visited. So this is my order vertex. Okay, 1, 3, 4, and my last is 1, because for 1 I break the while loop, so that means my cycle starts from here. Now I need to calculate the before sum, that which part is not occurring in my cycle. So what I do, I traverse my order array here and I check if my x equals to last or not, right? That means I come to these indices one by one, and if I check whether this is the this is the initial point of the cycle or not. If this is not when we are at this part, this is the before sum we need to maintain. So when cycle has not started yet, I add that in my before sum and I do k minus minus. Why so? Because we in total have k operations, and for these ones also we are consuming one operations, so I keep decreasing the value of k by 1. Now once I reach this the starting point of the cycle, right, that means from where whatever the rest of the indices I have, those ones values are part of the cycle sum. Like this sum will be calculated, like this sum will be keep repeating again and again. So I check whether when I reach that vertex, the starting point of the cycle, I mark cycle start equal to true, which means cycle has already started. And if cycle has started, then that does not come under the before sum. That means this is the repeating sum. So I add a of that index, and also I have increased the steps. Now I am maintaining steps. Steps initially was 0. What does this step means? This steps means that how many operations are we doing in a single cycle. Okay. Now my answer is this before part. I add this before sum. Then for this I have also decreased the value of k. Now I have some left operations k, and I check that how many times I can perform this cycle within the for this k value, and I just for this many times I multiply it with the repeat sum, because for this many times the repeat sum will occur. Now after that there may be some more operations k left, and for that I will do that in a loop, that I have remaining steps k mod steps, and my answer will be, currently my answer is something, right? And for that answer my index my next index where I will go is answer mod n. So for these remaining steps my answer becomes answer plus a of answer mod n, and finally I print this answer. So I hope you understood this problem, and this was the last problem, and that's it for today. So thank you for watching.